Hello, hi everyone. So today's topic is chiplets in VLSI by Radiant Semiconductors. So Radiant Semiconductors was founded in 2018. It's a end-to-end service-based company with main branch in Bangalore and other branches in Hyderabad and USA. So a brief about the presenter. So Casey has 18 plus years of experience in VLSI and currently working as a senior director at Radiant Semiconductors, taking care of end-to-end product development. Now let's talk about introduction to chiplets. So chiplets are small modular chips that can be combined to form a complete system on chip SoC. So they are designed to be used in a chiplet based architecture in which multiple chiplets are connected together to create a single complex integrated circuit. So chiplet-based architectures offer several benefits over traditional monolithic SoCs, including improved performance, reduced power consumption, and increased design flexibility. So chiplet technology is relatively new and is being actively developed by a number of companies in the semiconductor industry. Now, chiplet is a new type of a chip that is paving the way of designing complex SoCs. So chiplet can be considered as a high-tech version of Lego building blocks, right? So a complex function is decomposed into small module, then chiplets that can perform that single specific function very effectively. Hence, an integrated system using chiplets can consist of data storage, signal processing, computing and data flow management, right, which is built called as the chiplet. So chiplet is part of a packaging architecture and it can be defined as a physical piece of silicon that encapsulates IP, nothing but intellectual property, subsystem with other chiplets by using package level integration approach. We can say that chiplet technology integrates multiple electrical functions in a single package or a system. So utilizing chiplet technology, engineers can design complex chips rapidly and cost effective by essentially assembling different types of third-party IPs into a single chip or package. These third-party IPs can be IO drivers, memory ICs, and processor cores. The idea of chiplets originated from the project of DARPA chips, Common Heterogeneous Integration and IP. As the most advanced SoCs are not always acceptable for small-scale applications, so for improving the overall system flexibility, the chip plan seeks to create a new paradigm for IP reuse, which is chiplet. While computer technology is still largely dominated by traditional chiplets in most electronic devices today, it seems clear that this trend will change as time goes on. Many experts believe that specialized chiplets will become a common feature in consumer devices as these advanced technologies unfold. There are many reliable and cheaper technologies available for designing the chiplets. Right now, Moore's law is a prediction made by Gordon Moore, who is a co-founder of Intel, in 1965 that the number of transistors on a microchip would double approximately every 2 years, leading to exponential increases in computing power and decreases in cost. So chiplet technology can be seen as a way to extend Moore's law and continue the trend of improving performance and reducing costs in the semiconductor industry. Right? Now let's see some more information about chiplets as part of introduction. So one way in which chiplet technology can help extend Moore's law is by allowing for the creation of more complex and powerful SoCs without having to fit all of the necessary components onto a single monolithic chip. By breaking a complex SoC into smaller modular chiplets and connecting them together, it becomes possible to continue scaling up the number of transistors and other components without hitting the physical limits of a single chip. This can help keep pace with the performance improvements and cost reductions predicted by Moore's law. Nowadays, the heterogeneous chiplet integration market is growing more rapidly, Different microprocessors like AMD's EPIC and Intel's Lakefield are high in volume manufacturing with chiplet designs and heterogeneous integration packaging technology. So as you can see in the image, so it is AMD's Genia CPUs offering up to 96.96 5 nanometer cores across 12 chiplets, right? I mean, you can see 12 chiplets here, 6 here and then 6 here, right? Now let's go to the next topic, chiplets history. So let's talk something about chiplets history. Let's know how did the chiplets evolve. The concept of chiplets has been around for several decades, but it has gained more attention in recent years as a way to address the challenge of scaling down traditional monolithic ICs. With the continued advancement of Moore's law, the size and complexity of monolithic ICs has increased significantly, leading to higher costs and more difficulty in manufacturing. So chiplet-based design offers a potential solution to these challenges by allowing companies to use smaller, more specialized chiplets that can be easily combined and assembled to a complete system. The term chiplet is relatively new and has only been used for about 5 years or so. It was originally coined by researchers and scientists at the University of Michigan as they began investigating ways to improve computer chips design efficiently and functionally. The term is a combination of the word chip and the word petite, which can be translated to mean small. So a chiplet is a very small computer chip used in high-tech devices to perform more complex tasks than traditional CPU chips. It has developed rapidly over the last few years, and many experts believe that it will begin to replace traditional chiplets in consumer devices due to its enhanced functionality. So in May 2007, DARPA, which is nothing but Defense Advanced Research Project Agency, started its first COSMOS, compound semiconductor material on silicon, for heterogeneous chiplets. DARPA started chips whose purpose was to make modular computers out of chiplets. It also addresses different integration standards, IP blocks, and design tools available. Now let's see the market forecast of the chiplets. So according to information provided in the table, the chiplets market is expected to experience significant growth in the coming years. In 2025, the market is forecasted to reach a value of $5.7 billion according to a report published by Market and Markets. This represents a compound annual growth CAGR at 18.9% from 2020 to 2025. So in 2031, the chiplets market is expected to reach a value of $47.2 billion, according to a report published by Transparency Market Research. This represents a CAGR of 23.9% from 2021 to 2031. This forecast takes into account the increasing demand for high-performance computing and data analytics, as well as the growth trend towards modularity and customization in electronics design. These figures suggest that the chiplets market is poised for promising growth in the coming years. Chiplets are small, modular chips that can be combined to form a larger, more complex system on a chip (SoC). They offer a number of benefits over traditional monolithic chips, including improved performance, cost savings, and design flexibility. These factors, along with the increasing demand for high-performance computing and data analytics, are likely to drive of the chiplets market in the coming years. Now let's see some of the benefits of chiplets, right? Some of the benefits of chiplets and why they are challenging, right? Now, chiplets offer several important benefits over traditional monolithic processor designs. They can be customized and upgraded rapidly and easily, and therefore reducing development time and costs. Perhaps most importantly, chiplets improve performance by using specialized processing elements optimized for particular tasks. For example, if you need high processing power for AI applications in your devices, you could replace the traditional CPU with a chiplet designed specifically for AI tasks. In addition to these performance benefits, chiplets make it possible to reduce processor size and power requirements. By consolidating multiple individual functions into a single unit, they eliminate the need for much of the writing, cooling, infrastructure, and other components required by conventional chips. This lowers manufacturing costs and allows for smaller device designs ideal for mobile devices like smartphones or AR and VR headsets. The flexibility offered by chiplets also provides important design and development benefits because they can be customized and upgraded easily. Chiplets allow manufacturers to quickly adapt to changing market conditions or new technological developments. Right? They also simplify the production process by reducing the steps required to design and manufacture customized ICs. So chiplets technology can help improve yield as well, right, and reduce costs by allowing manufacturers to use smaller, more specialized chiplets rather than a single monolithic chip for certain tasks. This can help improve yield because it reduces the complexity of the chip manufacturing process, which can reduce the number of defects that occur and increase the overall yield of usable chips. Additionally, because chiplets can be designed and manufactured separately, it can be easier to optimize the manufacturing process for each specific chiplet, which can further improve yield. Another way in which chiplets can help reduce costs is by allowing manufacturers to use a mix and match approach to creating SoCs. Rather than designing and manufacturing a new chip from scratch for each new product, manufacturers can instead use a combination of pre-existing chiplets to create the desired SoC, which can be faster and more cost-effective. This can be particularly useful for companies that need to bring products to market quickly and need to be able to make rapid changes to their SoCs to meet changing market demands. Right? Now let's touch base on the chiplet challenges. The following challenges are encountered by the chiplets technology. The first and the foremost challenge is to ensure the low cost and high reliability of chiplet mode, and it is based on advanced packaging technology. So packaging technology is the focus of attention for chiplet. Its significance can also be observed from the positive shift of TSMC to packaging and development of other packaging technologies like INFO and CoWoS. The second challenge is to maintain good quality of product with an economical product rate. Even though chiplet is a certified product, but still there is a yield problem. The whole system of chiplet becomes more costly if some problem is found in one of the chiplet silicon chips in SiP. The graph in figure shows depicts percentage yield with respect to chip area. Another prominent challenge is testing coverage. Since multiple chiplets are embedded together, each chiplet can be connected to limited number of pins. Some of the chiplets become inaccessible outside the pins, which results problems in chip testing. Right? So let's continue to understand more about chiplets in part 2 coming week, and we'll also go through some of the interesting topics which are left out in the chiplets along with the summary. Thank you so much for attending this presentation, and we'll all catch up next week. Thank you.